Hello, we're going to take a look at 8.2 reciprocal function families. So it says graphing an inverse variation function. So an inverse variation, we know it's going to be in the format of y equals k divided by our x. So from here, we're going to graph this first function. So make sure you have a graphing calculator. We're going to go to 8 divided by our x, click graph, and we get these two curves in quadrants 1 and quadrant 3. So we're going to take a look and answer some questions based off of this graph. So I made a sketch that we can take a look at. The first part is the x-intercept. The x-intercept is where does your graph cross the x-axis. So right here, notice it approaches the x-axis, but it does not cross it. So we're going to put none. The y-intercept, it approaches the y-axis, it approaches it, but does not cross. So we're just going to put it to none. The vertical asymptote is where can I make a vertical line on my graph that my graph approaches it but does not cross. So notice right here in the center, we can make that vertical line that my graph approaches it from here, but it does not cross. So that would be my vertical asymptote is x equals 0, or just the y-axis. And then my horizontal asymptote, where can I make a horizontal line that my graph approaches but does not cross. So that would be my x-axis, or I could label it as y equals 0. Now my domain is, what are my possible x values? So it's always going to be all reals, but then we want to know if there's any restrictions. So my domain, it keeps getting bigger and bigger. My x values, it keeps getting smaller and smaller, but right here at 0, there's a jump. So I'd say all real numbers, but x cannot equal 0. Now notice I have a line connecting it for the vertical asymptote, and the reason for that is whatever my vertical asymptote is, that's going to be my restrictions on my domain. And then from here, my range is my possible y values. So it keeps getting higher and higher, it keeps getting lower and lower, but right here at 0, there is a jump in my graph. So it's all real numbers, but y cannot equal 0. And again, I have an arrow connecting these because whatever my horizontal asymptote is, that is going to be my restrictions on my range. Alrighty, let's take a look at this next one. We have y equals 12 divided by our x. So let's graph it. Notice the graph looks very, very similar. It's centered around 0, 0. So we'll look at that graph. We're going to go through and answer the questions. So the x-intercept, where it crosses the x-axis, it approaches this x-axis, but it does not cross it, so we put none. The y-intercept, it approaches it, but it doesn't cross it, so we put none. The vertical asymptote, where can I make that vertical line that it approaches but does not cross? So right here on our y-axis, or x equals 0, would be my vertical asymptote. My horizontal asymptote, where my graph approaches but does not cross, would be right here, my x-axis, or I could put y equals 0. And then my domain, my possible x values, are going to be all reals, but notice keeps getting bigger and bigger, it keeps getting smaller and smaller, but right here at x equals 0, there's a jump, so it cannot equal 0. Or it's going to be the restriction comes from the vertical asymptote, so all real numbers, but x cannot equal 0. My range then is my possible y values. It keeps getting higher and higher, it keeps getting lower and lower, but right here at 0, there's a jump, so it's all real numbers, but y cannot equal 0. Now we're going to start moving it left and right. Notice when it was centered around 0, 0, our answers were going to be the exact same. Okay, but once we start moving it left and right, up and down, then our answers are going to start to change. So please write down these transformations. We have y equals a divided by x minus our h plus our k. So this a is in charge of stretching, compressing, and reflecting. If the a is greater than 1, it's stretching. If it's between 0 and 1, it's compressing. And if it's negative, it's reflecting it across the x-axis. If it's negative and a number, then there's going to be two transformations. So for example, if that a is negative 4, the negative means it's reflecting across the x-axis, and the 4 means it's stretched by a factor of 4. This h is going to be in charge of moving it left and right. Because of the negative in front of it, it's the opposite of what you would think. And this k moves it up and down. So let's take a look at one of these. To get us started, it says y equals 1 divided by x plus 1 minus 2. So this plus 1 in the denominator means it's going to go to the left one. This minus 2 means it's going to go down 2. So if I take a look at the graphing calculator for this, let's make sure it goes to left 1 and down 2. So the denominator, I'm going to put it in parentheses so the calculator knows that's all in the denominator. Then I'm going to subtract 2 at the end. So notice this one goes to the left 1 and it goes down 2. And if we want to make those vertical and horizontal asymptotes, we're going to do so to help us answer those questions. So let's make this graph. It went to the left 1, so make that vertical asymptote. It went down 2, so make that horizontal asymptote. And then we're going to go through and answer our questions. So for the first part, it says, what is the x-intercept? So to find our x-intercept, we go to second trace, we go to 0, and then we want to go above and below this x-axis. So we'll go above it, click enter, go below it, click enter, and it crosses at -0.5. So that is our x-intercept. And then to find our y-intercept, we're going to go to second trace, we're going to go to 0, and we want to know, second trace, go to value, value. When x equals 0, what does our y value equal? So our y-intercept is going to be -1. And again, under second trace, just go to value, always type in 0 for the x, and see what your y value is. Okay, for this next part, it says, what is the vertical asymptote? So our vertical asymptote, where can I make a vertical line that my graph approaches it but does not cross? So right here at x equals -1, notice that's where I can make my vertical line, so it's x equals -1. And how I'm getting that, this x plus 1 in the denominator means it's going to the left 1. So whatever the opposite of this number is, that's going to be my vertical asymptote. And then this -2 means it's going down 2, so that's going to be my horizontal asymptote, y equals -2. Now, with both of those are going to be my restrictions on my domain and range. So my domain is going to be all real numbers, but x cannot equal -1, and my range is going to be all real numbers, but y cannot equal -2. And the reason for those restrictions, that's where the jump is on my graph. Alrighty, let's take a look at another example. So for this one, I have y equals x minus 4 plus 6. So the -4 means it goes to the right 4. The plus 6 means it goes up 6. So if we take a look at this graph, we can start to see it move to the right 4 and up 6. So let's make a sketch of that. Okay, for the first part, it says, what is the x-intercept? So my x-intercept, to find that, I go to second trace, go down to 0, and we want to see where it crosses this x-axis. So we go above it, go below it. Alrighty, and notice it says no sign change. For this one, looking at our graph, if we go back to our graph, right when I try to go below it, so when I went above it, click enter, I tried to go below it, but then it jumps back up here. It's not allowing me to go below it. So this, as the calculator is not allowing me to find the x-intercept. So what we're going to do, we're just going to take a look at the graph, and we can try doing second trace. We can try zooming and seeing where the x is, where the y value, is 0. That we can try to zoom, and it's not allowing us to find it on the table. So what I want you to do for this, if you get to a problem like this, just go to your graph and go to second trace. We can go to 0 and just move our arrows, and we're going to just round it. So for this one, it says 3.82. So this one's slightly different than what I have written down, but we can just write that decimal. So 3.83, or just 3.33 is what this calculator said, which is fine. For the next one, the y-intercept, we're going to see where it crosses the y-axis. So we go to second trace, go to 0, type in to value, goodness, I did it again, go to value, type in 0 for the x, and then the y is 5.75. So we write that down as our y-intercept. So second trace, the first one, type in 0 for our x and see what the y value equals. For the next one, the vertical asymptote is where can I make a vertical line that it approaches but does not cross? So this means it's going to the right 4, so the right 4 is where my vertical asymptote is, so I would say x equals 4. And then this plus 6 means it's going up 6, so that's where I can make my horizontal asymptote, so I say y equals 6. For my domain, it's going to be all real numbers. What my vertical asymptote is going to be my restrictions, so x cannot equal 4. And the reason for that, the x values keep getting less and less, keeps getting bigger and bigger, but right here at 4, there's a jump, so it cannot equal 4. And my range is all real numbers, but y cannot equal, and I use that horizontal asymptote, so y cannot equal 6. Notice it gets higher and higher, it gets lower and lower, but right here at 6, there's a jump, so y cannot equal 6. Now the last type of problem we're going to take a look at is writing the equation of a translation. So it says, what is the equation of the function? The parent function to use is y equals 2x. So looking at our graph, we want to come up with the equation for it. Now what I notice on this graph is the vertical and horizontal asymptotes. Notice my vertical asymptote is at x equals -3, and my horizontal asymptote is up here at y equals 4. Now that's going to help me to come up with my equation. Right here in the denominator, I'm going to use the opposite of this vertical asymptote. So instead of -3, I'm going to put +3, which means it's going to the left 3, like what my graph is showing. And then this +4, I'm going to put at the end, because that +4 meant it went up 4, so I put +4 at the end. So then my equation now shows this +3, it went to the left 3, this +4, it went up 4, so it matches. If I would graph this equation, I'm going to get this graph. So notice, whatever the opposite of my vertical asymptote is, I'm going to plug in down here, and what I'm going to plug in the same value at the end for my horizontal asymptote. So let's try another one. Has the same parent function for this one, so the parent function is y equals 2x, but my vertical and horizontal asymptotes are changing. So my vertical asymptote is at x equals +1. My horizontal asymptote is at y equals -4. So it's going to the right 1, and it's going down 4. So to go to the right 1, I'm going to subtract 1 down here, and to go down 4, I'm going to put -4 down here. Again, it's the opposite of this number down here, same as this number back here. And if I'm second guessing my answer, I would just go ahead and graph it and see if my graph matches.